Guys, welcome back. We're going to continue solving equations today, but we're going to have some special cases that we're going to talk about. So we'll go ahead and skip the warm-up part. But sometimes we'll have equations with no solution. So if I'm going to solve this problem, I want to get my x's together. So I would subtract x from both sides. Well, this x and x cancel, so I'm left with 4 equals, well, x minus x is 0, right? And since there's nothing left on the right-hand side, I want to write the actual 0. Now notice, 4 will never equal 0. That's not a true statement. So as soon as I see a not true statement, there is no solution. So when we've been solving recently, we get x equals some number or y equals some number. That's one solution. So we could get one solution or no solutions, okay? Another option would be something like this. So if I'm solving this, I would say, okay, I'm going to combine like terms. So 3x plus 5 didn't change. Over here, I get 3x plus 5. Then I want to go ahead and get my variables together. So I'm going to subtract 3x from both sides. And this 3x and 3x cancel, and this 3x and 3x cancel. So I get 5 equals 5. That will always be a true solution. 5 will always equal 5. So this would be all real solutions. Or sometimes we call this infinitely many solutions. Infinitely many solutions. Okay? And another word for these, no solution is inconsistent, and infinitely many is what we call the identity. Okay? Or it might be called consistent sometimes. Okay, so you might see some of those words on your bookwork today, so just be prepared for that, okay? So our options are one solution, no solution, or infinitely many solutions for a one variable equation. So let's go ahead and practice this. So why don't you go ahead and try this one and see what you get. So I'm going to distribute my 7, so I'm going to have 7x minus 21 minus 7x minus 21 equals 0. Well, 7x and 7x cancel to be 0. And then negative 21 minus 21 would be negative 42 equals 0. So this would be no solution. And we can shorten that to no sol. Okay. Let's look at this one. Again, I see some distribution. So I'm going to distribute the negative 1/4. So nothing changed on the left-hand side. Negative 1/4 times 4 is negative 1x. Negative 1/4 times negative 1 is a positive 1/4. I'm going to go ahead and add 1x to both sides to get my variables together. So I get 2x plus 1/4 equals 1/4. I'm going to go ahead and just shrink this down so I can actually fit it on my page here. Okay. So now I need to get x by itself, so I'm going to subtract 1/4 from both sides. So I get 2x equals 0. Oops, sorry guys. And then when I divide both sides by 2, I get x equals 0. So this would be a one solution problem where x equals 0. So as you're starting to solve, you might get no solution, you might get x by itself and get a one solution, or you might get infinitely many solutions. Okay. All right, why don't you go ahead and try this one now and see what you get. So we're going to distribute the 2, so we get 2x minus 2. Bring down my plus 3 equals 2x plus 1. Well, negative 2 plus 3 is going to be 1. So I get 2x plus 1 equals 2x plus 1. Now, if you notice right here that these two are exactly the same, you can say infinitely many solutions right off. But if you need to, you can always subtract the 2x from both sides to get the variables together. 2x and 2x both cancel, so I get 1 equals 1, which will always be true. So we could have infinitely many solutions, if you want to shorthand that word, or all reals. And you can shorthand that with this symbol here, with the double R. Okay, I would accept either answer there. Okay. All right, so I hope this video finds you well, and we'll talk to you later. Bye.